So for my presentation today, I will be talking about oral contraceptives and their development. While I was researching for my presentation, I sort of started to lean more towards estrogen and progesterone, which are the two components of oral contraceptives, and I'll talk about their development and how they were created, and then I'll also talk about how they work to actually prevent pregnancy in oral contraceptives. So just a little introduction about what birth control is and why it's important. Birth control, which is also known as contraception, are any methods or devices that are used to prevent pregnancy. And these methods work by either preventing sperm from reaching and fertilizing the egg, or by preventing the release of an egg altogether. And birth control is important for the most obvious reason: it prevents unintended pregnancies. It's also important because it gives women control over their reproductive health, and then it is also used to manage medical conditions. An example of this is endometriosis, which is a disease where tissue similar to the lining of the uterus actually grows outside of the uterus. And it's also used to help with menstrual cramps or irregular menstruation. So on this slide, it shows a bunch of different methods of birth control, but the one that I'll be talking about is the pill. So to understand how oral contraceptives work, it's important to understand how the menstrual cycle works. So this starts with sex hormones, and these are a group of steroid-based molecules that are used for reproduction and the development of secondary sex characteristics. So these characteristics include facial hair, muscle tone, and tissue development, and more things like that. So there are three major classes of sex hormones, and those include estrogens, androgens, and progestins. So estrogens and progestins make up the female sex hormones, while androgens make up the male sex hormones. But it's important to remember that all three of these sex hormones are present in both females and males. They're just present in different quantities. So the four sex hormones that are on the screen are the backbones that are modified by contraceptives. So estradiol here is the most potent, and when I say potent, I mean the most powerful or has the greatest effect. So estradiol is the most potent endogenous estrogen. Progesterone is the most potent endogenous progestin, and testosterone is the most abundant endogenous androgen, but it's not the most potent. So 5-DHT, which is the one down in the corner here, is the most potent endogenous androgen. So the next important part in the menstrual cycle is understanding the HPO axis, and this stands for hypothalamus, pituitary, ovary. So in this axis there are the two gonadotropin hormones, and that is the follicle stimulating hormone, which is the FSH, and the luteinizing hormone, which is the LH. And these two hormones are controlled by the hypothalamus, and that regulates the release and the control of estrogen and progesterone over the menstrual cycle. And then the pituitary, which is also a part of the brain, is in charge of making both of these hormones, and it also determines when the hormones are released. So there are 4 stages of the menstrual cycle, and those include the follicular phase, the ovulation phase, the luteal phase, and menstruation. So during explaining this, I'll refer to this diagram because it really helps to understand, and the most important part I find of this is looking at the hormone levels, because it just makes it all make a lot more sense. So on the diagram you can see between days 1 and 4 is the follicular phase, and then at day 14 That is the ovulation phase, and then the luteal phase, and then menstruation is actually at, I think, day 1, not at day 28, and that's when it starts. So at the follicular phase, FSH, which is one of those hormones, is released, and that causes several follicles to rise at the surface of the ovary, and each one of these contains an egg. And then at this point, estrogen levels start to rise. So you can see that FSH, which is the blue there, that one is present, and then estrogen, like I just said, begins to rise, so that's the gray line. As the estrogen levels rise, the endometrium, which is the lining of the uterus, begins to grow, and as the estrogen levels rise, the production of FSH starts to decrease. So you can see that the blue starts to go down as the gray starts to go up. And this is due to feedback inhibition. So as estrogen is released, the HPO axis turns off, which in turn releases less estrogen. Next is the ovulation phase. So as there is a decrease in FSH, there is an increase in LH. So you can see as blue goes down, pink starts to go up a bit. And as the LH levels rise, it goes to a sharp peak called the LH surge. So that is that pink peak that you see in the middle. And this is at the midpoint of the menstrual cycle, and that causes a release of an egg from the ovaries, hence the name ovulation phase. And then at this point, the follicle seals over, and that creates the corpus luteum. So at the next phase, which is the luteal phase, the endometrium, which is the lining of the uterus, stops growing, and then it enters the secretory phase. So at this point, the levels of FSH and LH start to decrease. You can see they both go down here. And then the corpus luteum starts to produce progesterone. So that's when the purple here starts to rise. And then the next phase is menstruation. So if fertilization has occurred, then the corpus luteum will continue to produce more progesterone, and then this prevents the endometrial lining, which is a layer of tissue that lines the uterus, from being shed. And then if fertilization has not occurred, then the corpus luteum will disintegrate, and that causes progesterone levels to drop, and that signals the endometrial lining to begin shedding, and that is what is the period. So a menstrual cycle, the interval varies between 20 to 35 days, but the average is about 28 days. So now I will talk about the oral contraceptives, aka the pill. So oral contraceptives are a combination of progesterone and estrogen, and the role of estrogen in the contraceptives is to control menstrual bleeding, and is also to make a woman's menstrual cycle more predictable. The role of progestin, that's what actually prevents the pregnancy, and the way it does this is it prevents the ovaries from releasing an egg. It also thickens the mucus in the cervix, which makes it difficult for sperm to enter the uterus and fertilize the egg, and it also thins the lining of the uterus so that there is less of a chance that the fertilized egg will implant into the womb and be able to grow. So the way that this actually works is through progesterone negative feedback. Negative feedback is a regulatory mechanism in the body where the production of a hormone is inhibited by the presence of high levels of that hormone. So when a woman takes progesterone in an oral contraceptive, it'll actually slow down the production of progesterone. So this works at the hypothalamus, and it decreases the production of those gonadotropin-releasing hormones, which is the FSH and the LH. So if the follicle isn't developing, then there's no there's an increase in estrogen levels. Oh, sorry, other way around. If the follicle isn't developing, then there's no increase in estrogen levels because the follicle makes the estrogen. So between the progesterone negative feedback and the lack of estrogen positive feedback, then there's no mid-cycle LH surge. And then if you remember from this diagram, there's none of this surge here, so then there's no ovulation, and no egg is produced. So there's two types of oral contraceptives, monophastic and multiphastic. So monophastic is a type of combination birth control where each active pill contains the same amount of estrogen and progestin. And then multiphastic is also a type of combination birth control, but the amount of hormone varies in each pill, and they're kind of supposed to mimic the normal cycle in an attempt to maximize contraceptive efficiency while minimizing the side effects. But both methods, or both types, are good. So estrogen was first crystallized by Edward Dowsey in 1928, and he did this from the urine of pregnant women. And then in July 1931, he held a second patent to manufacture and sell the product, and he sold it under the brand name Thelin, and it was first used as a woman's health aid, and the structure was later known as estrone. And then E.R. Squibbs and Sons came along, and they sold amniotin, which was an estrone extract, and that came from the fetal fluids of pregnant cattle. And then in 1932, another guy came along, Adolf Butenandt. Remember him for later, he comes back. But he was the first one to actually isolate the structure of estrogen, and he marketed that as prognon, I don't know if I'm saying that right, later that year. And then came along the Canadian firm Ayers, McKenna, and Harrison, and they introduced Emmenin, which was an estrogen isolate which came from human placentas. So all of these products weren't actually used as a contraceptive right away, and they were instead used to treat postmenopausal related symptoms in women. And this was an ad from 1941 for Thelin, and I just thought it was cool and I would add it in. The next thing that came along was Premarin, and it is literally what it sounds like. It comes from pregnant mare's urine. So Bernard Zondek, he was a part of the team who actually discovered estrogen in women's urine. He discovered that there's almost 4 times as much estrogen in the urine of pregnant horse than there was in the urine of pregnant women. So the solution to this was to purchase horse waste products from farmers, and then by the end of the 1930s, most companies had also switched over to horse urine. So the two estrogenic compounds in pregnant mares is equilenin and equilin, and these are both extracted from the urine as sodium sulfate conjugates. And this is why they're called conjugated estrogens, and you can see that like on this package of Premarin, it says conjugated estrogens. And so Premarin is a mixture of these equine synthetic esters of estradiol. So obviously the modern day oral contraceptives are not made from horse urine. And so this is when synthetic estrogens came along, specifically ethinyl estradiol, which I'll just call EE for short. So the reason that EE was created, so since estradiol was already one of the most potent estrogens that activates the estrogen receptor, the ER, the goal wasn't necessarily to create a drug that was better at binding to the ER. It was instead to create a drug that prevented the breakdown of estradiol. So EE was developed and marketed in 1943 as Estanyl. It was first used to treat postmenopausal women, but then in about the 1960s, that's when it started to be used as a contraceptive. So unlike estradiol, EE is rapidly absorbed, and it's also almost completely absorbed. It has a half-life of about 26 hours, so a woman can have a complete coverage for an entire day and then re-up by the time their next dose comes along. So this is why it's important to take oral contraceptives at the exact same time every single day to maximize their efficiency. And I included this graph or chart in, and it shows oral contraceptive Canadian products today. And then I just want to point out that for, I think, every single one of them, ethinyl estradiol, EE, is the estrogen component of the oral contraceptive. But you can see that the progesterone component is different in like a bunch of them, and that's what I'll explain next. So the same guy as before who isolated estrogen, he isolated luteosterone in 1929, but at the same time William Allen and George Corner isolated progestin, which was the exact same molecule that Adolf had isolated. So in 1935, at the International Conference on the Standardization of Sex Hormones, which does exist, in London, they compromised and then they dubbed the name progesterone, and it was just a combination of the two names. So nowadays, progesterone refers to the natural molecule, while progestin refers to any synthetic version of it. So, unlike estrogen, progesterone couldn't be extracted from one source. So the first isolation of estrogen actually came from sheep ovarian follicles and later from their wool. It was also extracted from cattle brains and spinal cords. So this made obtaining even 1 gram of progesterone really, really difficult and really expensive. But this was until the guy Russell E. Marker came along, and he actually was able to isolate progesterone from the roots of wild Mexican yams, which seems like really crazy to me, but this picture here is a picture of him with his yams. And he actually brought the price, these are in modern prices, but he brought it from the price of progesterone from about $80 per gram to $5 per gram. So this made progesterone able to be used medically. So this diagram shows a bunch of the different progestin contraceptives that are used in oral contraceptives today. It's important to know that the generation is just implying like when it was introduced into the market, and doesn't actually have anything to do with like the structure or anything. Although earlier, so like first generation progestins were developed mainly for their anti-gonadotropic effect. So if you remember, that's the FSH and the LH. So I'm going to butcher all these names, but I'll circle them. I'll start with first generation, but ethisterone was the first successfully discovered progestin in 1941. It had clinically useful potency, and it was actually synthesized from male sex hormones in an attempt to find orally active androgen. This progestin showed significant androgenic activity due to its similarity to testosterone, so this led to undesirable side effects, including acne, facial hair, and oily skin. So the removal of a methyl group from this gave norethindrone in 1944, and that resulted in 5 to 10 times more active progestin than ethisterone, that one, and then this other one here, norethindrel, was brought to the market, and it was really similar to the second one there, this one. So for second generation, there's not much of a difference between that and first generation, but it's important to note that levonorgestrel was the first progestin to be administered orally, transdermally, as in the patch, and also as continuous use, the IUD. And then for the third generation progestins, norgestimate was the first drug that metabolized into active progestin metabolite. So it metabolized into norelgestromin, and it also metabolized into the second generation one I talked about, levonorgestrel. It had high activity, and it was highly selective for the progesterone receptor, which means that it had little androgen effects. And then the next one there, nesogestrel, had really similar properties to the first one. And then the last one here, gestondine, had great progesterone receptor binding affinity, but it actually increased SHBG levels, which was a surrogate marker for blood clots, by about 200 to 300%. So you don't see that one used in modern day oral contraceptives. And then fourth generation progestin contraceptives were developed to have less of an androgenic side effects, so like acne and bloating. The second one here, drospirenone, was the only progestin with anti-mineralocorticoid activity. So basically that just reduced blood pressure and also improved cycle regularity. So yeah, that's everything I have, and